Hi again, science students. In this video, we're going to start looking at voltage and current. We're going to concentrate on a series circuit first. In the next video, we'll look at how voltage and current behave in a parallel circuit, and you'll be able to have a comparison of the two. So firstly, series circuits. So, current in a series circuit. Now, you'll notice with the series circuit that there's only one way for current to flow, or for charge to flow. And that means that the current is constant throughout the circuit. So a bit like a crowded hallway full of people where people can't push past one another. Everybody needs to walk at the same pace because there's only one way to go. Now, with regard to voltage, voltage is different for different resistors. So what that means is, let's say we've got two resistors. One is a 50 ohm resistor, say, and another one is a 100 ohm resistor. Well, more of the voltage is going to be used up, or more of the energy is going to be used up by the 100 ohm resistor. So that gets more voltage than the 50 ohm resistor. He gets more voltage, the 50 ohm resistor gets less voltage. So the big thing here to remember in a series circuit is that current is constant, but voltage is different. Okay, let's look at an example for voltage and current. And what this relies on here is simply Ohm's law. V equals IR. Voltage is equal to current times resistance. So in this example, we're going to find the total current and then the voltage across each resistor. Right, so for the total current, we're going to rearrange Ohm's law. Current is equal to voltage divided by resistance. The voltage in this circuit is 20 volts, and the resistance is those three resistors added up, 5 plus 10 plus 15. So overall we've got 20 divided by 30. Which gives us 0.666 repeating. We'll say three significant figures, 0.667 amperes or amps. So the current flowing through this circuit is 0.667 amps, and that's the same throughout the circuit. There's only one road for the current to travel along. Okay, so what is the voltage across each resistor? So let's look first at the 5 ohm resistor. Make a little heading here. So we're going to use Ohm's law here, V equals IR. So the voltage across this 5 ohm resistor is equal to, okay, the current times the resistance. The current through this circuit is the same everywhere. That's 0.667. The resistance of the 5 ohm resistor is 5. So the voltage across it is 0.667 times 5. Which gives us 3.335 volts. Now, for the 10 ohm resistor and the 15 ohm resistor, we use a very similar calculation, except the resistance will change. You might feel confident enough to pause the video and try that one on your own. Then I'll have a go at both of them. Okay, so for the 10 ohm resistor, 0.667 times 10, which is going to give 6.67 volts. The 15 ohm resistor, V equals 0.667 times 15. So the current through each of these resistors is the same. It's just that their resistance is different. So the 15 ohm resistor is going to get the most voltage out of the three. You can see that the 10 ohm resistor got twice what the 5 ohm resistor is getting. The 15 ohm resistor will get more again. 0.667 times 15 is 10.005. Okay, and as a quick check, circuits are greedy, naturally greedy. So that 20 volts which is being supplied is all going to be used up. So these three should add up to 20, these three voltages, because the circuit will use all the voltage. So 10.005 plus 3.335 plus 6.67 gives us, well, you know, with our rounding off, we just got slightly different to 20, but essentially adding those three voltages shows that all the voltage is being used up. So you can add up all your voltages and it should be the same as what is supplied. Okay, everyone, so the big thing to remember is in a series circuit, the current's constant throughout the circuit. So we just use Ohm's law with the total voltage of the circuit divided by the total resistance. Now the voltage drop across each resistor is different if the resistors have different resistance. So we use their resistance and the total current of the circuit individually to calculate each of their voltage drops. Okay, go and check the description for the video and try some of those questions.